Disruptors and curious minds, welcome to the Good Ship Thinking on Paper. In a world increasingly vibe-coded by 20-year-olds and run by billionaires, this is where you can think about the impact of technology for yourself. Keep listening, and the algorithm can't touch you.
When you look at the per mile greenhouse gas emissions of an electric vehicle versus a conventional gasoline car, the electric vehicle wins. The demand for lithium through 2050 is projected to be 2,120% increase. And so it's just huge. Overwhelmingly, that demand is fueled by energy storage, whether that's in a laptop, a cell phone, or an EV or a grid scale battery. We in the U.S. we produce a very small amount of the global share of lithium. We don't even make the top 9. So it's tiny. What is a global problem of climate change turns into a really local problem for individual communities. In the U.S., it can take 29 years to get a mine up and running.
From 29 years. What is the environmental impact of getting lithium and copper out of the ground? How are we measuring that environmental impact? And as the thirst for EVs and the electrification of everything just increases, why does it matter so much? Today's guest is Jennifer Dunn. She's a professor of chemical engineering at Northwestern University, and she spent her career trying to answer that very question. So welcome to the show, Jennifer. Thank you for thinking on paper with us today.
Yeah, thanks for having me.
We know what's happening in each and every one of these mines. We know what the damage is. We know what the impact is. It's all documented and recorded, surely, isn't it?
Actually, it's really not. And it's really hard to figure out. We've been working towards that. And we've been kind of learning about the different ways that different mines are being held accountable or, choosing to sign up for reporting some of their burdens.
This conversation started initially about rare earths, and they get all of the press. They get all of the Hollywood. It's all about the rare earths. And I think it's because they're called rare earths, but lithium and copper and these other minerals are equally important. Why don't they get the attention that the rare earths get?
It's a really interesting question. And I think a lot of it has to do with China's having the lion's share of rare earth supply chain from start to finish, from mining these minerals out of the ground to manufacturing with them. And in a way that's very sort of from an energy security, from even a defense aspect, because we use a lot of rare earths in defense technologies, that's concerning. And so I think nations like the U.S. are interested in finding ways to improve the security of the rare earth supply chain and relying less on a country like China for those minerals. And so I think that is one reason why there's such a pressing need to shift the supply chain for those minerals. Whereas, as you mentioned with lithium and copper, we're primarily looking at nations like Chile and Australia, where we have, sort of more stable relationships with those nations. And so perhaps the supply chain security is a little bit less of an issue, but the increase in demand is quite large over time, over through 2050 or so. And so then the issue is more we're going to need a lot of this, and less about we're really worried that we're going to get cut off from the supply of these minerals.
Jeremy, spot quiz. How many lithium mines are there in the United States of America?
I think they just dusted off one, didn't they? Wasn't there isn't there one? Yeah? Did I get it right?
Yeah, there's one operating mine. And one of the students in my group, we are getting, I hope, very close to getting a new paper out on planned expansion of lithium mining in the United States and what that would mean for water stress, especially as the climate changes. And so through that work, she was like, yeah, there's only one that operates right now. But there, in her analysis, she looked at 117 planned mines that she considered. I think she boiled it down, the analysis, to around 50 or 60 of those for the actual modeling work that she did, because, many mines are, in general, many types of facilities are planned, but they don't come into existence. She had some criteria for filtering those down.
Where is it? Where is the one?
It's in Nevada. It's in Nevada.
How does it compare on a global scale in terms of size and production?
Oh, we in the U.S. we produce a very small amount of the global share of lithium. We don't even make the top 9. So it's tiny, and I think that's But at the same time, if you read reports out of the International Renewable Energy Association, IRENA, like demand for lithium through 2050 is projected to be 2,120% increase, and so it's just huge. And so we, hope to meet a large portion of that through efforts like recycling. But it's sort of unavoidable that globally we'll need to increase the production of lithium from mines. And I think the U.S. now has decided like this is a real priority for the nation.
Has that been driven by EVs and other sustainable tech? Is there what else is in that picture?
Drones.
That's a lot of drones. 2,000% increase. That's a lot of drones.
Yes, I mean it's EVs, and this is global, so that demand number is not just for the U.S. But I mean, overwhelmingly, that demand is fueled by energy storage, whether that's in a laptop, a cell phone, or an EV or a grid scale battery, which as we deploy more and more renewables for whatever purpose. Of course, the energy storage piece always comes up as a part of how to make renewable energy more reliable, more sort of available to us, even as we always say, when the sun isn't shining and the wind isn't blowing. So I think that it's really that demand for energy storage that is pushing that demand for lithium higher and higher. There are other much smaller uses for lithium, like in lubricants and somewhat in medicine, but those are not the reason why this is skyrocketing.
Is it fair to say that your work is looking at what the impact of extracting these elements out of the ground is doing? And can we talk about does that make the impact of the energy transition to cleaner energy more challenging, more difficult, more maybe wash out because we're not doing the right stuff on the front end?
Yeah, I mean, from analysis we've done and others have done, when you look at the per mile greenhouse gas emissions of an electric vehicle versus a conventional gasoline car, the electric vehicle wins. It has fewer emissions per mile. So if your lens is primarily focused on we need to decarbonize transportation, then of course we're going to go with the EVs, right? And climate change is probably, in my opinion, the most pressing challenge we're going to face as a society. And it's a global problem. But then, when you start to think about these supply chain issues around supplying EVs and these other needs we have for copper and lithium, which we can talk about other demand besides just the batteries themselves. And you start to think about what's the impact of acquiring these elements or these minerals from the ground. It's pretty substantial. And what is a global problem of climate change turns into a really local problem for individual communities, where mining can deplete water supplies. So 16% of the world's mines exist today in water scarce areas. And when I mentioned this study that my student and I are on the cusp of getting out in the world, there's not enough water to meet the demand that these mines will have, especially in the southwest of the U.S., Nevada, for example. And it's interesting. Okay, so water consumption is an issue. Water pollution is also an issue. And so communities face this risk of having, just in general, additional emissions to water from mines that happen. So in the US, you'd get a mine would get a permit, right? And they would be allowed some level of pollutant emissions to water. But that is, now that baseline is zero, that mine doesn't exist. And so inevitably there will be just more pollution because as mining expands in the US. And so then the question is, well, what's the impact of that? And of course, this is when we've looked at this atlas. It's called the Environmental Justice Atlas. And we did this for globally. We looked at what are communities worried about as mining, it's actually not even as mining expands, it's an existing mining. And we looked specifically at minerals that are part of the energy transition supply chain. And a lot of it is water. They're worried about just, again, this water consumption and then water pollution, because of course people use water for all sorts of things, to irrigate crops, just to drink, and for many other uses. And so whether it's depleted because there's less of it, or it's depleted because now it's not drinkable anymore, or requires so much more investment to clean up the water before you can drink it, that's a problem for communities. We also see communities really worried about changes in biodiversity, which, in my opinion, I'm a chemical engineer, so biodiversity science is, of course, not my wheelhouse. But I think as just a scientific community, we're first starting to understand what do we lose when biodiversity declines in terms of ecosystem services that help keep us healthy and keep us well and help the environment function as it should. And so I think that we don't fully understand the impacts of mines on biodiversity, but this is something that communities are really worried about.
Could we just go back to the water issue? So copper mining, notoriously water intensive. I've got here like 70 to 100 cubic meters of water per ton of copper. Some information. So Chile using 30% desalinated water. But I'm interested in the lithium mining because there's two types of lithium mining. Like lithium is found in two deposits. You have hard rock deposits and you have brine deposits.
Yes.
And how it is mined is very different between those two sources, and the water consumption in each of those is very different. Could you walk us through the difference between hard rock and brine deposits for lithium, and then how the water impact changes depending on which method?
Yes. So I had to log back into my computer. Apologies for that. But yes, we did, as part of this paper I was mentioning, we looked at the water consumption for these different types of acquiring lithium, or different methods of acquiring lithium. And the literature has a pretty wide range for some of these methods. So brine, on the median number we pulled for just brine extraction was around 200 meters cubed per ton of lithium carbonate. And then when you move to something like requiring brine from geothermal, the data is scarcer. So for the lithium brine extraction, we were able to look at 22 studies to try and pull those numbers out. For the geothermal brine extraction, there were only 6 that we could find at the time in the public domain, and that was like much higher. It was closer to 300. But hard rock for lithium is actually a much lower number. But again, we're a little data limited. There were only 3 studies that we could find in the public domain that reported these numbers. And that was closer to let's say 80 meters cubed per ton. So actually hard rock is not like water consumption for hard rock lithium mining, from what we can tell based on what's available to us, is not necessarily like more concerning from a water consumption standpoint than the brine extraction methods. So that's, somewhat reassuring. From an energy consumption standpoint, I've had the very good fortune of being able to visit the SQM facility in the Atacama Desert in Chile. And, it's a lot of kind of like waiting for water to evaporate. And so as from an energy perspective, it's not that energy intensive. And I remember when I was first starting to look at these questions back, it was about 2010, when I first started thinking about these things. I remember doing some of this math around the water consumption and energy consumption, of brine extraction. And I thought, this is really not a big deal. I mean, I was just at the very beginning of this journey. And I thought, well, for an energy perspective, extracting brine is like not a big deal. And I remember even back then, they're like, listening to the radio and news stories, people were already starting to talk about some of these issues. And I was like, the lithium's not a big deal. But I was not at all at that point in time focused on water and thinking about the impacts on water.
On the research of the brine deposits, the water table has been decreased because they're using so much water to dilute the lithium that they're actually lowering the water table, which obviously has secondary effects all over the water basin.
It does. And this is really an interesting point. We had a workshop in Chile about a year ago, maybe a year and a half ago. And we had a group of indigenous community leaders from the Atacama Desert speak about some research they had done with the university in that region that really showed the water table declining. And this was of great concern to them. But when you talk with some of the lithium companies, they say this is not consistent with what they are finding. They are not finding this. And it's really interesting because, for example, SQM has real-time water table measurements that you can go and look at on the internet. And so, these are efforts at transparency and communicating with the community about the impacts of their mine. And to me, that's actually one of the very few examples of where communities have some real-time access or very near real-time access to some of these data about water consumption effects. So that is very admirable. But it was interesting to hear from these community leaders that this remained a big concern and that their science was showing a little bit of a different result. And so I think this will continue to be an ongoing debate. And yeah, I think that just to bring the lens back to the US for a second, there is a lot of local resistance to expanding mining. There's these dueling narratives of more jobs versus these impacts on the environment. And there's been an effort in the US to try and speed up the permitting process because of these kind of delays. So in the US, it can take 29 years to get a mine up and running.
29 years?
Yes. The permitting process is really involved. And there's a lot of legal action, right? So people are suing to try to get mines stopped. And this was what happened in Minnesota for this mine. It was a copper nickel mine that's been proposed, and it's been in a holding pattern for quite some time. And just recently, the Trump administration lifted mining restrictions on the boundary waters in Minnesota, which is not right where that mine is proposed. But Minnesota in general and Michigan are part of the copper range, the iron range here, the iron range here in the U.S. And so this is like a region that's really kind of under the microscope for additional copper mining, in addition to, of course, Arizona is another sort of big area for the U.S. for mining copper, where existing copper mines are. So, there's this concern around community engagement, and just communities have the power to stop or slow these processes. And so, when we think about if we need these minerals for various applications and we think it's important to build new mines, we have to think about how do we help communities understand these impacts. And it's always more expensive to adopt more pollution control. And it's a global market, right? So you're competing as a mine, you're competing on a global market. And if the US legislators are saying you need to, or permitting process results in more stringent pollution control, your per ton numbers, dollars per ton, are going to go up, but you might not get the chance to open your mine, or you might need to slow opening if you're not satisfying the concerns of communities and local regulators around things like water pollution and water consumption. So that's a trade-off that I think we don't really know enough about. Like, as an academic, I'm very interested in that trade-off. I don't ever need to open a mine, so I'm not concerned about making money. I'm just really interested in that trade-off and what it means for like a secure supply chain, a supply chain that helps us advance the energy transition without doing as much as we can to limit any sacrifices of local community.
I read somewhere, I can't remember if it was in one of your studies or in my wide cast of research on the subject, that there is potential to mine wastewater. Like, there's potential minerals within wastewater that we could take advantage of that we're not currently. And how does that compare to like how we evaluate the mining process in general?
So it's true. And some estimate that in the US alone, if we were to recover minerals from waste streams from mines that have closed and mines that are operating, we could meet a lot of our demand for minerals. I think the hard part is that oftentimes minerals in waste streams are very dilute. So like their concentration is really low. And so, that's why they weren't recovered in the first place, was that the economics are more challenging when you have these dilute or low concentrations. But now the market has definitely changed, right? And so I have an economist friend who says, like, we will never, ever, never run out of these minerals, because if the demand is high enough, we can accommodate higher costs for recovering these minerals from laptops and or from mining waste streams. And to me, that is a really exciting possibility. And I get to do some work with collaborators who are interested in developing technologies to do just that, whether they're using biology, like proteins that are really selective in extracting specific minerals. There's also kind of like a soup that they're in of other things that you might not want. And so selectively recovering what you're interested in these waste streams is really interesting. So, so as a chemical engineer, it's like, okay, well, we could use bio-based or bio-inspired methods. We could use adsorbents that focus more on chemistry, and instead of like more chemical or maybe more traditional chemical engineering approaches to doing that. There's people interested in using electrochemical based methods to do that. So, and this is a really active research space right now in the US. So I'm sure you're aware that the US government has really dramatically sort of decreased the amount of federal funding for science research in our country. But this area of recovering minerals from wastes remains an active area where like the need, it's so obvious that we need to work on this, that it is an area you can still obtain funding. And so there's that's pretty kind of a renaissance of research in this space.
Beyond the wastewater, what about the recycling in general of existing technology which is full of lithium and copper?
Yes. So, I heard this really interesting talk last year at the American Institute of Chemical Engineers convention, where this was at Michigan Tech up in the Upper Peninsula of Michigan. And they had actually gone to a landfill and extracted e-waste, basically. And they were, I think the mineral they were trying to get back was nickel. And they were like, this is really hard. So, when we think about like urban mining and landfill mining, it's a really interesting topic. But again, like the economics and the technical challenges are pretty substantial. And it's just kind of, messy. And so, nonetheless, I'm really excited about work like that. And so that's like getting it back out of a landfill. But of course, I'm sitting here surrounded by multiple electronic devices that will expire in the next, I don't know, at most 5 years. And so like my library has a program where I can go drop off my e-waste. But nonetheless, this is also still an area where the economics are a little bit challenging, and there's a need for technology development. And this is still, the federal government's also funding research in this space, and there are lots of startups trying to make this a reality. And I think it will become a reality. I think it does face some of the challenges that plastics recycling faces in terms of like the distributed nature of the feed stream. So, at a mine, like everything's like right there. But in this world of getting minerals back from spent electronics, you just need to rely on people to not keep everything in their drawer, like their literal drawers in their house. Bring it to a recycling center. And of course, the other challenge is that the battery chemistry is changing over time. So companies are trying to maybe limit cobalt, for example, in energy storage devices, regardless if it's an EV or a laptop, because of the cost and also some of the environmental and like sort of social concerns around cobalt. But cobalt is like a high value mineral, and it might be a reason why you want to recycle in the first place. Whereas lithium historically has had like lower costs. So a battery that has lithium iron phosphate chemistry, for example, there's not necessarily a super high value component of that battery. And so that's another project we're working on, is really thinking about like what makes the economics work for recycling lithium iron phosphate batteries, where Tesla is kind of going, right? Or they've already gone. So yes, like spent device and spent battery recycling is going to be a really important stream. I think we're still working on the engineering of those systems, and we're still thinking about the social engineering of recovering these devices from the broader public.
So,
and even getting them back out of landfills. Yeah.
Well, get all those old Teslas, they'll be starting to fall apart by now, and then must be those first Teslas. Where did Tesla get their lithium from? China, I guess. We've got a mine, so it sounds like, okay, there's a lot going on with recycling, but such is the demand we have to mine. I was very
Yes.
surprised when you said there's only one mine in America, but there was potentially 150. But then you said it takes 29 years to get a mine open. So maybe that's one of the reasons. But we have to mine. So LCAs, Jeremy, over to you and the LCA question.
Well, I think when we started this conversation, Jennifer, you mentioned the creating a common framework or language to assess the impact on the front end of mining some of these things. So talk us through what LCAs are, why they're important, what you're doing with them in your work, and what people need to know about them.
Yeah, so life cycle assessments is basically a methodology that can be applied to any system of study. We're interested in applying them to mining. And the way that life cycle assessments work is that an analyst or a researcher will think about, for every step of a mine's life, even from back to exploration and all the way through closure, and then maintenance post-closure, which can be, decades, what is every unit of energy, every unit of water, and various chemicals that are consumed to produce all the minerals that mine will generate over the course of its lifetime. And we also want to think about, over the course of its lifetime, how much does the mine, how many pollutants does the mine emit? So we're concerned about things like dust and air pollutants, like NOx, for example, because mines combust diesel fuel in mining equipment, and that does contribute to air pollution like NOx, volatile organic compounds, and so on. But also emissions to water, whether that's minerals or various chemicals that are used, or sulfates is a big area of concern in Minnesota, for example. So we try to sit down and build a diagram. We call it our system boundary diagram, that has lots of boxes and arrows that connect everything. That's a very typical chemical engineering thing to do as well. And we try to figure out, how can we quantify all of these flows? Now, if I were a mining company and I was in existence, I would have all that information, right? Like, I would know how much diesel fuel I bought for my mining equipment last year. And I could figure out, how much emissions arose from the use of those fuels in my equipment. I would know roughly how much water I used, how much natural gas I used, how much electricity I used, because I'm paying bills, right? So when you're inside a company, undertaking life cycle assessment is perhaps it can be hard to gather all that information, but it's easier than me as an outsider trying to figure this out. So the way that we in my group try and figure out energy and water consumption and pollution from mining is through using permitting documents. And if the mine exists, what they've reported, if they've needed to report their emissions to the federal government, what they've reported. And so through figuring out the consumption and emissions over the entire course of the life of the mine and how much minerals have been produced over the life of the mine, you can calculate then the total emissions or energy input per unit of product. So you can imagine, like, per unit of copper. I mentioned, so mines are also interested in electrifying their equipment, and they use electricity anyways with their existing equipment. And so we don't just take the amount of electricity that's used on site, we account for the energy that's consumed to make that electricity, whether it's from natural gas or from coals. We consider the upstream emissions and energy consumed from getting all of the fuels to the power plant, for example.
Is that scope 3 that we've been here with this? Is that?
Yes. So in like corporate carbon accounting, something like that would actually be called scope 2, the emissions from the power plant. So like the on-site emissions are scope 1, and then going one step upstream is the scope 2. And then scope 3 is like associated often with like consumer use of products. And it's very hard to quantify scope 3. In LCA, we don't necessarily divide things up in those scopes, especially like for like water consumption, because we're looking beyond carbon accounting. But we do, like, the words life cycle are meant to indicate that we don't just account for the on-site burdens, but we also account for the upstream burdens in figuring all this out. And so, what we hope to be able to do is to be able to, as best we can with the information we can get our hands on, develop these comparative impacts for different mines. And so we've been working on that. It's, everything takes a while. So we've been working on that for the US, and then we've been working on that for Australia and Chile. So I've been very fortunate to receive support from our Buffett Institute for Global Affairs here to work with undergraduates and also partners in Chile and Australia at universities to try and figure this out, to help us understand how emissions are reported, for example, to governments in Chile and Australia, because it can be hard to navigate those websites, even for our own, the websites I'm familiar with. The US government can be a little tricky. And then when you go to another country, you got to learn the ropes. So it's nice to work with partners who already know the ropes. And so you can imagine a world in which we're able to, through using a method like life cycle assessment, come up with these per ton impacts that can be compared across different mines. And you can really understand, well, if I source my copper from Australia versus Chile versus Arizona, what are the relative environmental impacts? And of course, we care about greenhouse gas emissions, but as we discussed, water consumption, water pollution are really important metrics to consider.
Once you have this data collected, and if the mines in Chile or the mines in Australia or the mine in America the impact is this,
Mm-hmm.
then what? Once we know that, what do we do with that information?
Well, in my view, there are kind of two things we could do with that information. It depends on the sort of stakeholder group. Actually, maybe three things. So one thing is, if the government, under the previous administration, decarbonization was a big priority. And there were incentives put in place in the Inflation Reduction Act to try and encourage decarbonization technologies to take off in the US. These include the lithium-ion batteries. And there was a provision in that act to try and shift the supply chain for batteries and for minerals to the United States. And there was a portion of that policy that said that the EV that is sold is only tax credit eligible. So they offer tax credits, so consumers would be more interested in buying EVs. But the vehicle would only be tax credit eligible if 80% of the market value of the minerals in the battery came from the US, from Chile, or came from the US, from a US free trade partner, which include Australia and Chile, among other countries, or recycling. And the recycling had to happen in North America. So they put this policy out, and the focus was on the market value. But a student and I wrote a paper that explained, A, that those targets were nearly impossible to meet by the deadline, which was 2027, but B, that accounting for the market value didn't really address this concern around the environmental impacts and the social impacts of acquiring these minerals. So if the U.S. government is encouraging this policy, it should also account for the environmental burdens and try not to put more burdens on individual communities. And so we made that argument, then knowing that these types of metrics don't really exist in a comparable way. And so one stakeholder is a government, whether it's federal or state level. The EU currently has a battery passport program where they are looking solely at the carbon emissions associated with producing batteries that are used in the EU. But the mining step, they basically just give you a value. So if you say, well, this is my battery chemistry, they can give you a value for what are the greenhouse gas emissions associated with producing that battery at the mining stage, which to me is a big mistake. That they are not looking more directly at what is the supply chain, and that they're only looking at greenhouse gas emissions. Because
is that better than nothing, or is that actually worse than something?
I think it's better than nothing. And I think it is, really admirable that the EU legislators realized that through pushing towards decarbonization, they are creating this demand for a whole supply chain that's, relatively young, and that there is an opportunity maybe to steer it towards being less carbon intensive. So that's great. And I think, it at least gets people thinking about it and doing something about it. And oftentimes, not always, but carbon emissions are oftentimes tied to things like water consumption, because if you're making the process more efficient overall, maybe you're going to emit less emissions from using energy like natural gas or electricity, but you're also needing less water to run that process. So the things can be coupled and have co-benefits. So I think it's a great start. I hope that they continue to kind of drill down on some of these other effects that are really felt by local communities. So category one of who would use this is governments if they want to and you can say, well, why should a government care? And part of it is, well, if you think decarbonization is important and we need more mines, you want communities to feel comfortable with having these mines. So part of that is the environmental burden. So if you say well, we now have a stipulation around the environmental burden needs to be like at or below a certain number, or you get certain sort of credits if the lower your number is. Like those are ways that a government can sort of encourage better performance, better environmental performance in the supply chain. So there's governments, then there's companies, and I think that companies might want to tailor their supply chain to be less environmentally impactful, in part because the less environmentally impactful your supply chain is when it involves mining. I think that there will be, one way of saying is less community resistance. And so there's less risk in your supply chain. So the better you can do in acquiring your minerals for, if it's an energy storage device, from mines that are operating in a very socially and environmentally responsible manner, you have less risk of protests, for example, going to shut that mine down, which happens around the world somewhat frequently.
But less profit.
Yeah, exactly. So that's the reason why a company might want to do it, even if they think like, well, maybe corporate social responsibility might not be their top priority, but there is a risk of supply chain disruption from adverse environmental consequences for communities near the mine that's supplying them. And then the last stakeholder category is the communities themselves. So, we've worked with communities in Minnesota who are, told like we need these mines because we need to do the energy transition. And then they think, well, why us? Like, what role does our community, our location play in this broader supply chain question? And is it really true that, we can have better environmental performance, for example, for nickel mining here in Minnesota than other places that might mine nickel, like Indonesia? So being able to tell that story to a community and really for a community to understand themselves, how they feed into this broader decarbonization goal, I think is important. And we have seen how communities, like, it's helpful to them to understand, like we've presented LCA results to a couple of communities in Minnesota, and it's helpful to them that they're like, oh, okay, like I understand now how this fits into this broader story. And it helps understand like where, if they're going to push towards encouraging companies to take action to reduce pollution, where should they put their focus? That's another thing that life cycle assessment can help you do. It can help you pinpoint what is kind of like the worst offender in this overall process, that if you were going to pick one thing to say, this is what we need to work on to improve, that helps you identify that one thing.
Give me an example, because your work is super important. What you're highlighting is super important, but it's very long-term benefit to humanity focused versus short-term profitability driven, which is unfortunately the means of the way the world tends to operate. Give me an example of a frustrating moment where you've been heads down in your research and you're just tired of hearing about the economics, tired of hearing about this and that, and you just want to grab someone by the shirt and just be like, listen, what do we need to listen to?
I think what's frustrating is that like the technology exists to give communities and governments and consumers more information about the environmental effects of mining. Like, technology is there. It's just that to adopt that technology and potentially adopt more expensive pollution control technology that costs money, and for that reason, it's not attractive. But to your point, it's the long-term thinking of like, well, people are going to get upset, when water quality declines, when we are now talking about, we have been for a while, but water rights in the Southwest, like who gets the water? I think that there's just not maybe an appreciation for how, if the investment was made to provide more information and to provide more efforts to protect water quality and water consumption, that would generate a lot of goodwill that could translate into less risk to the operation, either from lawsuits in the US, or, we don't see as many like protests, people going to shut down facilities as happens in other countries, but does happen in other countries. And so I think that is very frustrating, because many mining companies have, community relations activities, and they will invest in the community, they will build a new school, and those are all wonderful things. But I think that what's frustrating is, even though the technology exists to do a lot better with information sharing and pollution control, it's just, when you do out the balance sheet, right, the risk calculation side of it isn't there. It's very hard to quantify, and so it doesn't come into play.
If you're doing something as important as this to the world that affects the world in such an important way, there should be a should be some kind of process that puts that into place to make it go. Yeah.
I want to be sure to mention that there are industry initiatives to report like sustainability standards for the mining industry. It's not that those don't exist. And we reviewed kind of what their requirements are. And really, this sort of transparent reporting or calculating a life cycle result is never required. There's one standard called IRMA that I think is like best in class, in my opinion. And it does like sort of offer one of the things you can do when you are a mine working with that standard is you can say you will make data available upon request. Primarily around air pollution. And so, but then as a community member, like you need to know that's an option. You need to know how to do it. And it's very challenging as compared to what SQM is doing with this, like having the sensor data available online. You still need to know what to do with that, but at least it's there and you need to go through the whole process to request it. So in my view, that mining standard is a great start. And there's so much more that we could do, again, to address like the cynical view is like we want to limit risks to shutdowns of mines because we need to plow ahead with decarbonization. That's kind of like maybe the more corporate way of looking at it. And of course, the community way of looking at it is like we want to protect our environmental quality where we live.
I like cynical. I can do cynical. So back to the differentiated market. I drink fair trade coffee sometimes. I eat fair trade chocolate sometimes, not all the time. But it's something that I understand culturally. It's in me. I've grown up with it. I understand it. What you're talking about is kind of the same thing, but for lithium and copper. Can it work for lithium and copper? That's not coffee. It's not a consumable that we're all eating and drinking. I know it's all in our technology. I'm surrounded by it. It's literally all around me, but I don't think about it in that way.
Yes, I think that's, part of the problem is like from a consumer perspective, we're not consuming just copper, right? So, and there are certification standards. So like if you buy stuff on Amazon, there are some certification standards that apply to electronics. But again, it's like very qualitative and in my opinion, kind of squishy. But even if it were quantitative, we've done this, as you're saying, like there are lots of like eco labels for lots of different kinds of products, and that's not necessarily my area of expertise, but from when I hear people speak about this at conferences, it's that there's so many labels, and consumers don't necessarily know like how best to interpret those labels. Like, so fair trade coffee, I think that one has like jumped the shark, or like that is like now like mainstream enough. And so, but the problem I see with a consumer facing sort of label like that is that every device has like multiple minerals in it. And then there's like the rest of it that has to be manufactured somewhere. And so it's a really complicated supply chain. But I think it's, definitely worth thinking about. And we have technology like blockchain to help us do a better job tracking, even compared to 10 years ago. But actually the New York Times—
It's been a while since anybody said that on Thinking on Paper.
Yes. I think that, and then there's just lots of ways I think that we can leverage advances in technology to try and make this a reality. The New York Times just had a piece, I think on the 26th of April, that was talking about gold. The U.S. mints gold. And there had been some legislation in Congress to try to limit the chances that gold would have been acquired from mines that have social and environmental problems. But it's not working. So the New York Times tracked some of this gold to like Colombian drug cartels. So it just gives you a sense of like someone's really trying, to do right here, to do this well, and it's not working. For something like gold that is just used as gold, it's not like being put into a device. It's just gold. So it is hard, and there have been efforts to like there's 3 T's, tantalum, tin, and I'm forgetting the third, where people tried to like develop one conflict-free diamonds, right, is another one that's a big deal. These are my grandmother's, so I didn't acquire new diamonds, but yeah, so I think that but those also have problems, right? So like if you look hard enough, you're going to uncover cases where something that's sold as a conflict-free diamond is not, and so now we're just growing them in labs. But yeah, so it's like I don't want to like say this would just be easy. Like it's hard, but I do think it's I think it's worth doing.
Yeah.
100%. No, two quick comments there. We aim to connect the dots on thinking on paper. You mentioned gold, you mentioned blockchain. There was actually a study comparing the mining of gold to the miners in blockchain. Gold actually didn't do as well environmentally as the miners in blockchain, believe it or not. But
I'm sure there's some mafia and some nasty, nefarious parties involved in Bitcoin, probably more so possibly than gold.
Could be possible.
Yeah.
But this conversation real quick, like as we're talking about like telling the story, right? Because this is story. Culture starts with story. Mark, you mentioned culture. We know it with fair trade coffee. It's acceptable. It's kind of a sense of like if you're drinking it or you buy it, you feel like you're contributing and you're doing the right thing. So picture this, you go on to Apple's website, it's time for a new laptop, and you're looking at the models and you're seeing that comparison chart, you know, the Model A, Model B, Model C. Model A is the cheapest, it's pretty fast. Model B is a little more expensive. It has another chip in it that makes it does something. Model C, fair trade, copper and lithium for a premium. How does the world react?
Yeah, I had a friend a while ago. She had a phone that was meant to be conflict-free, all conflict-free minerals. She's the only person I've ever met who had a phone like that. I think that, and because she just really, it was a top priority for her. And I think that, we are hearing so much about affordability. I think that, especially in today's environments, people are just focused on cost effectiveness and things being affordable. So I don't see a world in which consumers are going to really move on this opportunity for lower environmental impact products, electronics, like an Apple laptop, except for a small group of folks who have that extra sort of disposable income. Yeah, it's pretty hard because it's also like we're talking mainly about things that aren't happening in the US. And so I think it's really, I'm of course speaking as a US person, I think it's hard to kind of like really have that click for people. And to, we are also just bombarded with all sorts of things we should care about. And it's just, I think for many people, even me, like who has some training in this area, it's like, it's a little bit overwhelming to know like, well, which things can I do that will really make a difference? And I think that is like, if I'm going to spend extra money on whether it's fair trade coffee or my laptop, like which one should I do? And that's really hard to offer that kind of comparison. Yeah. So it's tough.
We need Brad Pitt. We need Brad Pitt, and we need a movie. We need a big, huge Hollywood blockbuster to change the cultural view of all of this. Conflict-free phones sound incredible. Do you actually remember the premium that your friend paid for that phone, or where they got that phone, or how it compared to?
This was back. I used to work with her like in the 2016, so we're talking a decade ago. But I do remember it. Frankly, it didn't work as well because it wasn't like a famous brand. So she would get frustrated with it. But she said, "Oh yeah, but it's like the responsible phone to get." And so she was willing to tolerate, lower performance for this phone. Now, again, this was 10 years ago, so I haven't kept up with like how these options are available.
Just a quick search. There's something called Fairphone Gen 6. Whoa. That's out right now.
And that's a conflict-free phone?
Conflict-free phone. Conflict-free earbuds. Wow, interesting.
It's quite scary that makes me realize, or perhaps think, that almost everything is conflict tech. Everything I'm surrounded by.
Yeah.
Yeah.
Conflicted.
Right. So that's one very specific, social impact, which is really an important social impact that we want to avoid. Sourcing minerals from areas that like the existence of mines causes conflict. And I did a study with a friend. I think we published that in the 2021 ballpark around cobalt from the Democratic Republic of the Congo and some of the social concerns around that, and thinking about like, it's very difficult to quantify those effects in the same way that life cycle assessment can quantify some of the environmental effects. So she is an anthropologist. Her name is Sarah Young, and we were trying to figure out like, can we do this? And the answer is really hard. So I had a point here. So conflict is just one of many social ills, and it's super hard to quantify. And then it doesn't get to like the challenges of things like your water is polluted, and so Yeah, I don't know. I guess as an engineer, I'm wanting like this like even playing field for assessing all of these different problems that can arise in the mineral supply chain. And then, you need to work with people who really understand how do we communicate this to the public, so something gets through all the other noise that people are dealing with. How do we communicate the importance of this to policymakers? And how do we continue to work with industry to, help maybe advocate for doing these types of sort of transparent data collection and sharing can limit your risk of losing your what I think of someone as a social license to operate.
Jennifer, thank
Perfect.
you for thinking on paper with us. That was awesome. We have to do a part 2 because we've only just started, really. I wanted to talk about processing. I mean, China processes much of they like, what is it, 15% of the global supply. They process 65%. The boom bust cycle of minerals.
Yeah.
But
Yeah.
we'll save that for next time. I just want to leave
Okay.
you with a thought, with a depressing thought, a cynical thought.
Oh,
That
no.
yes, the metals that are critical today might not be so critical in 10 or 20, 30 years. And perhaps what we're doing now, or what you're trying to do with lithium and copper, will set a precedent that when those metals do inevitably change, check out our episodes on quantum computing if you want to know, if you don't believe they will change. And there'll be something, a process, a cultural foundation to make sure that we don't make the same mistakes again. So thank you for enlightening our audience. It's been superb.
Well, thank you. It was a pleasure to speak with you. And yeah, happy to chat again.